Okay, so here we've got question 2 from the CWC test, which is asking us to use calculus to find the turning point of the curve with this equation. So using calculus, trying to find a turning point tells us we're going to need to differentiate. So the first thing I'm going to do is differentiate this function. And if we look carefully at the function, we'll see it's the product of e to the 3x and cosine 4x. So we've got to use the product rule. So the first thing I'm going to do is split the function into a function u being 3 to the x, e to the 3x, and v being cosine 4x. I differentiate each of those functions, so this differentiates to 3e to the 3x. You could use the chain rule for that, or you might well just have learnt that one. And similarly for this one, cosine 4x differentiates to negative 4 sine 4x. I then use the product rule, which tells us to multiply the diagonals and find the sum of those two terms. So there's our rule that I'm going to use, and the first method mark is basically for using that rule. So if I substitute things in, I've multiplied these two terms to get negative 4e to the 3x sine 4x, and then multiplied these two terms to get 3e to the 3x cosine 4x. And that will get me an accuracy mark. I probably want to tidy this up a little bit. I can factorise this because there's a common factor of e to the 3x. So if I take that out as a common factor, I then in the brackets get 3 cosine 4x minus 4 sine 4x. So I've differentiated the function, and we were actually asked to find the turning point, so we should know that the turning point is always found when the derivative, the gradient, is equal to 0. So my next step is I'm going to put this function equal to 0. So here I've got the function from the previous slide, and I know that that needs to equal 0 at the turning point. So I've got the product again of two things here, e to the 3x, and then this expression in the brackets. So if I want the expression to equal 0, I know that either of those two things can equal 0. So I can say e to the 3x equals 0, or this function here can equal 0. But we have to be a bit careful here, because if you think about the function e to the 3x, you could think about the graph of that, what it looks like, or just the fact that you can't raise e to any power to get the answer 0. So this one has actually got no solution at all, and we need to have made sure that we've stated that that's an option and then explained that we're discounting it because there's no solution. So the only solution must be from this side. So we're going to try and solve this equation, and to solve that, well, it's got a cosine in it and a sine in it, so we only want one trig function really, but I know that there's a relationship between cosine and sine, and that relationship is that sine over cosine equals tangent, so I'm going to try and get it in the form of sine over cosine. So I can move this over to the right hand side and then divide through by cosine 4x and divide through by the 4. You should be able to get it to this point, so just have a play around, make sure you know how to get from this equation here to this one here. And at this point I've got my sine over cosine, so that we know is the same as tangent. So I can say that tan of 4x equals 3/4. And there's another method mark there for trying to solve this equation. So this is what I need to solve. There's my equation there. I've got tan of a function of x, so my suggestion would always be that you change the 4x into u, but if we're doing that, then we have to remember to change the domain. So u is equal to 4x, so I multiply each of these by 4 to get my range for mu. So pi over 4 becomes pi pi over 2 multiplied by 4 is 2 pi. So that's my new domain. And worth saying that you're saying that u is equal to 4x. So to find the first, the principal solution to this, I'm going to do the inverse tangent of 3/4. And if I do that, it comes out to be 0.6435. Now, unfortunately, a lot of people forgot that you need to check that this lies within the given domain for u. Pi is 3.14, so we need answers bigger than that. It's certainly not bigger than 3.14, so this is actually not in the range. It's not a solution to our equation. So to find what is, I would suggest sketching the graph of tangent, or you might use the unit circle. So here is the solution that we've just found, 0.6435. The graph of tangent repeats every pi radians, so the next one is going to happen pi more than 0.6435. So I'm going to add pi to 0.6435, which gives me this solution here. I have to remember that that solution is for u, not for x, so I've still got to work out what x is, but I know that 4x is equal to u. We might consider whether there's any more solutions. Well, if you imagine adding another pi on from this one, from 3.78509, so it would land over here. It would definitely be outside this given range again. So it looks like that's the only solution for u. To find a solution for x, we clearly need to divide through by 4. So if we divide that by 4, we get the answer 0.9463. This is an equation really that we have solved. So we've found a value for x here, and so we can check that equation here. So I've just substituted it into the function or the expression we had on the previous slide, and you can see it's come out to be very, very close to 0. Okay. Alternatively, you could have used the derivative function on your calculator to differentiate this function with this value of x, and it should have come out to be about 0. And that's it for this question. Again, if you're not sure about anything in the video, please go along to a subject extension to get some help. Thanks.